Linux is a good OS for a machine for copying the data off a failing hard drive. Not necessarily, Kelly, because I mean the tool you would use is like as what DC3DD, and you can use any Linux to run that. Pull up the chat. If you're copying data off of a failing hard drive, it doesn't necessarily matter what you're using as long as you can get the data out. Okay, it's 2:01. All right. So we are in module number 4, and we stand 1/4 of the way through the entire semester. So far, so good. This module is supposed to cover 3 chapters, but tech being tech, one of the 3 chapters that we're going to cover has become obsolete. So in its place, I have 2 links to show you. So this first recording will capture chapters 10 and 11, and then we'll do chapter 12 next. So chapter 10, performance tuning and system recovery. Performance tuning establishes important things. That's key number 1 is establishing a baseline. Key number 2 is recognizing any bottlenecks. And from those 2, tuning the performance to ensure that Windows runs as smooth as it should, or as smooth as it can. A baseline is important no matter what you do, whether that is installing an OS that you're going to deploy out to multiple systems, whether that's configuring a server. You need to have a baseline. You need to know what the machine is supposed to do, the load it's supposed to be carrying, the amount of data coming in and out. You really need to understand what is happening on the system and what should be happening on the system. This will help you immensely when you have to troubleshoot. If you have to guess what is an anomaly, that's just going to take too much time. But if you create a baseline when the system is at an acceptable place, it will make your life so much easier when you have to deal with problems. When you have that baseline and you're able to identify what is normal, you are then able to figure out anomalies like bottlenecks. For example, a disk bottleneck. If you realize that a disk is running slower than it should, well, the only way to know that it's running slower than it should is if you have a baseline of its performance. Then you're able to quickly distinguish this specific drive is running slower, so we can either switch the disk or upgrade or whatever needs to happen. But that is only possible if we know how the system is supposed to function. Same with memory. Just because those are chips doesn't mean they won't fail. If a program suddenly is requiring more memory than usual, we can begin investigating that because we know what the normal is for those applications. A virtual memory used to be an important thing when we had spinning hard drives. Now with SSDs, the virtual memory is pretty much a moot point, just because it runs as fast as the regular memory. So loading information in and out of virtual memory is pretty easy. And if you're not familiar with virtual memory, it's basically a page file that is saved on your hard drive, any program that's up and running but isn't requiring RAM gets sent to the virtual memory to hang there until it's needed. So if you're running on a slow spinning disk, it's going to take a while for that data to get back up to memory to be used. But now with SSDs, it's not a problem. Again, having a baseline will help you realize when there is a processor bottleneck, when there's too many processes running. Because what define too many? Well, that depends on the baseline of the system. Then from there, you can see what you can do, like upgrading the processor itself or adding additional if the motherboard can handle 2 or more, or using multi-cores. Off the top of my head, I don't remember if virtual memory is used for S3 sleep, but as long as the system is utilizing memory, you can have data fly over to virtual. I know if like hibernation, it will take all of memory and put it into the virtual disk or the virtual memory to hold there until the system is turned on again. Just like the other points, you also have networking. If the computer is making too many connections at once, if it is trying to DOS the system, if it is trying to send odd communications, the only way to know this and identify this is if you have a baseline. So once you have that baseline and you know what normal is, then it's very easy to find those variations. And when you find those variations from the baseline, it's easy now to take the appropriate steps to fix that problem. As always, you should document any changes you make. Windows comes with native tools to monitor the performance, normally called perfmon. It's an MMC snap-in that has some important areas for you to use. You don't have to install other tools. You can use these native tools. So here's an example of the overview of the performance monitor, telling you the idle time of the disk, telling you CPU information. You can dig deeper into the performance monitor and get more information. For example, the real-time monitoring of resources. You can look at the CPU and look by the processor IDs to see which process is running. You can control any process that might be going a little out of control. Here's what it looks like for a CPU. In this case, we have two programs that are currently suspended. They're not running in the CPU. They're just hanging for now. Those are the two in blue. The others are actually running. You see their processor or the process ID. You see the overall usage of the CPU. And you also see on the chart that not too long ago, within the minute, we've used 100% of the CPU. Disk will tell you the disk performance. Again, it shows you the snippet of the last minute. Same with networking. Tells you any TCP connection details, since UDP is connectionless. Also tells you how memory is doing and how much memory is being used. The performance monitor, it has your visual displays that you can use. You can sort things in different ways. There's the counters that you can divide out to see processor, memory, physical disk, so on and so forth. It's handy because it does come with charts that you can create along with a report. So if you need to add it into a ticket, if you need to visually show the difference between normal and abnormal, it's great. When creating the baseline, you can use the data collector sets when something weird is happening. It's an anomaly that we need to dig into. That's where the data collector set can also kick in. And it'll log all its information to disk. This is not always running, and that's actually ideal because if you don't need to record everything that's happening, then that's okay. So great for baselining and great when a problem is brought up and we need to investigate. You can configure alerts, which is great. That way you're not looking at these logs all the time. So it can either do things like log in an entry in the application event log or start a collector set and run a scheduled task. Your data manager will be in charge of controlling the specific log files that were generated by this set. And you can specify any policies needed, like how much free disk space are we gonna dedicate to this specific thing, the maximum number of folders we can create, any report generation, and what are we gonna do when we run out of this dedicated space? Can we get rid of the old stuff to make room for the new? Your reports are processed log files. You can specify specifically what you want to see. Normally, you don't need to do that, but just if your report is unique and it needs specific information, you can edit the report for your needs. The task manager, we should all be familiar with it, how it looks, what to do with it. So I don't spend too much time, but this is a tool that you can use. And to get to it, you could either right click on the Windows bar and select Task Manager, or do Control Shift Escape to pull it out. So again, this is just a quick run through of the Task Manager. Things that we have seen since like Windows 95. You see the processes and the information for each process that's running. You can set an affinity if you so want. You do have the services tab, which didn't exist in the task manager for the longest time, but now you can see the running processes and their status. There is the performance, which again has been around for a while. The new thing about it is it does link to the resource monitor. So if you wanted to dig further, you can. As you can see, here's the usual thing that we see, and then open resource monitor down at the bottom. In Task Manager, you can also see any app history, the users. If we need to log somebody out because they've been disconnected for a while, you can do that from the Task Manager, along with what applications start up as soon as a user logs in. Your performance options has things like the visual effects, the processing schedule, and virtual memory. It's sitting kind of buried because you got to go into System, into the Advanced tab, and then the Performance section. In the tabs, you have like the visual effects. If you want to turn off like Windows Arrow in order to not get all the cool graphics because you need to run in a less graphics mode, you can do that from there. You have your Advanced tab that says what programs, if a program runs in the background, what kind of priority does it get versus the programs that you are running yourself, like Word or Firefox or Brave or Zoom. Within the Advanced tab, you see what you can define for the virtual memory. And normally, Windows can handle it. If you want to specifically say instead of using the C drive, use the D drive, you specify that here, or specify not to use a page file at all. The DEP, the data execution prevention, is here. This basically ensures that any a program does not go to unauthorized memory space, for example, where Windows itself lives. The kernel is sitting outside of user space in memory so that no program, no malicious program can get access to it and take full control of the system. This thing is only looking at the Windows specific programs that make the operating system run. And it does come into play if a piece of malware tries to get into that space to make the kernel do things it shouldn't. If you've ever worked with Windows, you know that errors suck because they tend to not be detailed. They tend to be really vague, and you have to go on a long goose chase to find the event ID and find others with the same issue. They have been getting better, but I wouldn't say it's the best thing ever. There is this little item, the steps recorder. If you can't get to a system, but the user is complaining of a problem, you can use this to capture a screenshot every time a user clicks on an item. And it's saved in a format that they can email and read later. It's not a keylogger, so a user would have to add some comments for later review, but it does at least take screenshots as a person is clicking through something to show a problem. Anything that shows system stability that we can graph goes under the reliability monitor. So we have things like when a piece of software installs or uninstalls, any application failures, any Windows failures, or miscellaneous. The event viewer. I tend to avoid the event viewer. I'd rather use something like Splunk to read data. But if you don't have Splunk around and you need to look at what's happening on the system, the event viewer is your next best choice. You can pull it itself as an MMC or open up computer management and get to it. You'll see all the logs that are happening everywhere, along with what you can do to troubleshoot. Here's what event viewer looks like. You have places to filter. It used to be that you couldn't find more information, had to Google it yourself. Now you can click on the online help and it'll take you to the event ID and hopefully will provide you with information to dig further. So not only do you have application install, uninstalls, you also have things like security log, which keeps track of who logged in when. You have the system log for any general operating system stuff, applications and services. Anytime a program ran and created an event, that's where that gets saved. You can put a custom view to see specific things that you choose, along with any subscription to copy events from a remote computer to yours. So if you're trying to monitor a system that you can't get to physically, if you set the subscription node on ahead of time, you're able to pull those events over. You can search by event ID, you can search by source. There's a number of items you can search by to get information that you need in order to find out what happened with the program or why it closed, why it's not working, etc. File recovery is an important item. You should be doing backups of your important data. You should not just assume that the system will work always. It'll either be corrupted in memory, data can be corrupted on the disk, in transit, a power outage or power surge. There's many things that could happen to cause memory to fail. You want to have a backup of your information. Yes, Event Viewer is the Windows equivalent of syslog. File history is one way to do a backup on the system. It's good if a user accidentally deleted or accidentally modified a file that they shouldn't. You can restore it back to a version that Windows knows. It would not be, I would not recommend file history as a form of backup because it's saving on the disk itself. And if that disk fails, then out it goes. But it is great if you're using like Windows Server and you're sharing files and somebody accidentally overwrites a file. You could use file history to quickly restore the file and avoid total mayhem. It's just not something that you should use as backup. See, in this case, we're backing up to a different volume. This is better, where we're taking what's happening on our system and we're backing up that data to a different drive. This is better. Some more optional settings where you can exclude a certain folder or folders. But you do ideally want to back up to a external drive or a network drive, something off of the computer that's being backed up. There's the one utility that you can use to clean up any backed up files, because as you create more versions of it, that's going to take more disk space. So you always want to be careful how many files you're using file history on, because it has to keep track of each and every one. The backup and restore is still around. Windows 10 uses it. You can also use any plethora of tools to back up a system, like Acronis and whatnot, to back up systems. But you do have, at the very least, you have a tool native to Windows. So here you can set up a backup that'll either create a system image, a system repair disk, and backing up where you're going to run data to. The first time you set it up, of course, you have to say where the backup will go. And then from there, it'll do it on a regular basis. Yeah, you could have a NAS system with ZFS and share that with others. And as long as Windows can read to it, then it could save it there. In this case, our backup is saving any files that are in the libraries and personal folder files. So it's not backing up Windows itself. It's backing up the user's data. In this case, if Windows dies and we don't have a system repair disk or a system image disk, we'll have to reinstall Windows, but then we'll be able to use our backup to bring back the important files that were in libraries and personal folders. So you want to be clear as to what your backup is actually saving. When we need to restore, it can be through either previous versions if we have that enabled. Otherwise, we could just restore from the backup. Here's previous versions. Again, this is saved locally. You can choose which to back up from. We could look into the history and maybe pull out whole folders from the past. It is also possible to back up the OneDrive data. If you just accidentally delete something within OneDrive, it really just goes to the recycle bin so you can bring it back. If a Windows system doesn't boot, time to use some form of recovery. You can either do system restore, which again, this is saved on the local drive. This is assuming that the local drive is still functioning well and did not get corrupted. From here, we could also call a backup from another location. We can specify what disks we're protecting. You can have more than one restore point. It is automatically triggered by things like updates or scheduled tasks or applications that can trigger system restore to function. You can also use PowerShell to do these kinds of things, and here are some commandlets that you could use. Either way, you can bring up system restore and see what points you have to restore from. You can also use the Windows recovery environment to pull system restore. As long as we can read the disk, we can use that to pull out any restore images to bring back. It used to be a very big problem to have the right driver installed, but more and more drivers are showing up in Windows Update that actually work and have been signed and tested. So this is not necessarily a bad thing anymore, but just know that you still are able to roll back a driver just in case it doesn't work, due to instability or it causes Windows to crash like it used to, or blue screen. You can roll back a driver. Within Device Manager, you would click on any of the devices. Under driver, you can roll back. As long as there is a driver to roll back to, you'll have that there. The recovery drive will contain the Windows system files and any recovery tools necessary. Again, this is something you want to have on an external drive in order to have it handy just in case system goes down and we need to restore. It does require admin privileges to run. Windows RE is a great environment. If you ever worked with not sysinternals, Windows, what was it called? Oh, MS Dart. If you look up MS Dart, that is an array of tools that you can use to recover Windows. That comes with Windows RE. So if you ever find MS Dart as an ISO, that's a great set of tools that are already built in to help restore any Windows systems. How often would you recommend backing up your computer? That depends on the work that it's doing. I've had servers where they would back up every 15 minutes, every hour, every 6 hours, every day, and the backups would roll up throughout the day. It depends on the data that you're using, the data that you're working with, and the needs that you have for that data. It could be that backing up once a day is fine, or backing up once a week is fine. It all depends on the sensitivity and the necessity of the data that we're talking about. Windows RE, it's possible to pull up when you are on a system and you get the F5, F8, you can pull this up. Within it, you have the traditional things like safe mode with networking, disabling automatic restart, debugging mode, that kind of stuff. There is a possibility to reset Windows 10, getting rid of all the applications and setting everything back to default. If the computer can't boot Windows, then it's kind of hard to do this reset. At that point, you'll need something like Windows RE to boot from in order to restore. And at that point, you can define to either keep or remove all data. Good questions. Any others regarding this chapter? You can restore like a user account information to a fresh machine. As long as the two boxes are identical to each other, it's completely possible to restore, kind of like you would taking a backup image of one system and deploying it elsewhere. The advantage of having system reset over an install disk is it's happening from the disk. So as long as the disk itself isn't bad, it would be faster to reset the system over installing from an install disk. A disadvantage would be if the physical disk is bad. That's not going to work so well. Also, if you have a malware who is a persistent, it's not going to be a good thing to try to reset because it'll probably realize it and find a way to stay on the system even after the reset. Yes, it does require the system partition to be intact. If you have a custom Windows setup, you can save that image to. You should be able to save that image to a restore partition because it'll be tied to that system. You're basically creating a backup of that custom system in case when Windows dies. Right, it's not a setting. A recovery partition isn't a setting that's already enabled. You have to turn it on. So that's probably why you don't see it in many systems, but you do see it in a lot of OEM systems, and it'll restore along with all the bloatware that the OEM had it with. I know when I used to have Windows, I would get rid of that recovery partition because it came with all the bloatware, even if I tried to get it out. So I would have to wipe the whole drive and install Windows Fresh and create a restore partition that wouldn't have all the bloatware. Right, with things like that, McAfee being pre-installed, or other bloatware that I don't want. I see more typing. Would I install the OEM automatic driver and firmware update program? You know, those aren't actually bad. I would go with the OEM. But there used to be a whole lot of other bloatware that was unnecessary. A quick talk about chapter 11 before I stop this recording, because I said this would have both chapters. Chapter 11 in the book actually covers Microsoft Intune, but Microsoft Intune is actually a thing of the past now. It's now Microsoft Endpoint Manager. So I'll put the link and put it in the live stream channel. If you want to get a little tour of it, here's also the link. But Intune is what this has become, where you can handle multiple devices, multiple endpoint devices in one location. So you have, there's the Intune console as it used to stand, but now is part of this, where as long as the systems are part of the domain, we can control them, we can manage them, like updates, configuration changes, so on and so forth, in one umbrella. It can handle things like BOID. It handles zero trust, especially with so many people working from home. You have to have something like zero trust enabled. The device doesn't have to be enrolled into our system, but we can still protect our data. We have better analytics than we could with Intune. It scales because it's running on Azure, and should be a good return on investment, because again, we're dealing with many systems that are everywhere, especially now. And how do we protect our data, which is the most important thing for us? And this whole infrastructure is built around that. I suggest doing the tour, get yourself familiar with this new infrastructure that has replaced just the one. So I would not expect Intune as a separate item anymore, because it's now under the endpoint manager. Okay, so let's make a video of that. So that'll take a little bit. Perfect time to stretch, move around. As an IT manager, would I rather port forward my DC, my domain controller, or would I want to do a VPN? I would go with your third option of having everything in the cloud, because I don't trust the system that my users have. I'm going to assume the worst, because that's generally right, that they have systems with outdated operating systems, or they haven't installed all their updates because it's an inconvenience. I don't know if they have any proper security products in place. So I'm going to assume the worst. And I would have As an IT manager, I would set up everything on the cloud, have the users log in through their browsers, and be able to do all their work through the browser on cloud machines. This way, I can prevent any leakage of information out, because if it's in the cloud, I have control over where the data, where the company data is going, and able to see where it's going, and not accidentally or maliciously be copied out or removed or whatever. Correct. I would give them a login uh, to log into the cloud through like Guacamole or Apache Guacamole or something like that, so they can have access to their machine and have access to company resources and data. But I would not rely on their home systems to connect to my network, because I do not trust them. If bring your own device was not allowed, and the work from home systems were company provided, and I had full control of the device, yeah, I wouldn't have that same policy, because that computer would, for example, have USB turned off, so you can't copy company data um, out of reach, for example, or I would have the thing completely in a VPN, so that it won't get affected by whatever's around the user's home network. It would be a pain, but that would be better. And I am uploading that video. Chapter 10 and 11 into the 194 playlist, not made for kids, public. Says 47 seconds left. There are, it's a long question, but the basis is how do you have a domain user access the domain when they're outside of the domain, like they physically leave the domain? There are ways to connect, to have a computer phone back home when they leave the network. Or you could do things like you can only access the network through a VPN or a cloud infrastructure. There are ways to that users can work outside of the physical environment and still have connection to the infrastructure that we're trying to protect. Okay, so that video is up now. So I can remove this and record the next one. Okay. Chapter number 12, Client Hyper-V. Virtualization is awesome. It allows us to use more of the resources that exist on our systems that we don't necessarily use, because we're not always using 100% of the CPU, of memory, and of other resources that we have on systems. But through virtualization, we are able to do so. A hypervisor is basically the program that will take an operating system and allow it to run. Basically, it turns operating systems into these little programs, because the physical hardware does not realize that we're virtualizing it. It just sees a program is running, like a browser, like Discord. It sees a program running. What's happening within that program is we're virtualizing memory, CPU, and all that. So we have our physical hardware, our physical CPUs, our physical memory, and so on and so forth. We have our hypervisor, which will create these operating system spaces, these computer spaces, and within that we'll install various operating systems and be able to manage them. Because this is all software based, the physical hardware doesn't really exist to the virtual machine. It sees virtual drivers, virtual device, because it's all software based. So there is a program that is acting like a hard disk. There's a program that is acting like memory, acting like the CPU, acting like the network card, so on and so forth, in order to make this happen. Windows 10 has the Hyper-V capability, so you're able to run a OS within Windows 10 in order to do things like software testing, any demonstrations, any training. This is great as a test. I like virtualization as a testing environment. It is possible to run another virtualization instance within a virtualized instance. That can get a little nutty, because you're virtualizing twice. And as long as you have the resources and capability to do so, it could work. Just know that it might crash too. There are a few items that are not available in the server version of Hyper-V versus the client. So for example, in the server, I can take a virtual machine and replicate it while it's on another server. Can't quite do that in client. It's going to stay within one physical box. sleep and hibernate do exist within the host OS and client V, not so much in Hyper-V. Mostly because you don't want Hyper-V to go to sleep. You expect Hyper-V to stay on all the time. Of course, it's not included in home or mobile or any 32-bit system. It has to be 64-bit. It has to have the CPU capability to do virtualization. Hyper-V itself can be its own OS. It's basically a server core with the Hyper-V role and nothing else. You can check before you enable it. You can check to see that everything that you need is there to be able to do this. It is a feature, so you can either do it through PowerShell, through through DISM, or in program and features. You'll need to reboot the computer in order for it to load the necessary files in order to run. So here it is in Windows features. You'll need to click on the root folder and it'll enable all these items in order to install everything you need for Hyper-V. The four main components that any virtual machine needs are CPU, memory, disk, and network. As long as you have enough resources, you can run as many VMs as you can. You could use PowerShell commandlets to manage. You can also have the MMC snap in order to manage your systems. Virtual switches, they come, they're important when we have multiple systems and they need to connect in different ways. You tend to have one switch that'll connect out to the physical world, and then other switches can be virtual. Because again, the virtual machines themselves, when they communicate out through their NIC card, that is all software data. That is not actual, and it's not a real packet that's going out to the world. You can configure it so that everything works within, and you'll see much higher performance than you would in a physical network. But again, it's all software, so it's kind of cheating. Here's your virtual networking. You can create private networks and internal networks that, again, don't need to connect out to the world. One could connect virtual machines to each other or virtual machines to the host. You can, when you create a VM, you have the choice of generation 1 or generation 2. Generation 1 will be for anything that's old, that needs, like if you need to run, like, I'm just going to throw something way out there, like Windows 98, you're going to use generation 1 versus generation 2, which would be running anything with a UEFI, so like Windows 8 and 10 and any of the latest servers. Here's the difference between generations 1 and 2. If it's Gen 1, it's going to be BIOS based. It won't have secure boot. It'll have an IDE or SCSI. Disk controllers, you can have the old legacy or synthetic network adapters. They'll have a floppy drive. In generation 2, UEFI based, secure boot is there, SCSI only, it'll use synthetic. No floppies. Your virtual machines can have any of these states. It can either be off, running, starting, paused, or saved. When you look into the VM itself. You be able to see the GUI if one exists and be able to interact with it as though it's a physical box. The virtual machine connection can do quite a number of things, from mounting disks to install operating systems to doing checkpoints. A checkpoint, if you've never heard of checkpoint, that is basically snapshot for anybody who's familiar with the VMware world. You could also use the remote desktop client to connect over the network to a virtual machine. Again, I would highly, highly, highly encourage you to not use the RDP protocol in the open internet. It has been breached. It is compromised. I highly, highly recommend not using RDP at all. Your integration services is just the same as VMware's tools. That'll give you the drivers you need in order to allow the virtual machine to work smoothly in its environment. Here are some of the integration services that'll be installed when you add the integration services. So it'll be able to do data exchange. It'll be able to do a guest shutdown. It'll do quite a number of things that makes life easier to work with. And I would recommend installing the integration services into your VMs. Because it is acting as a physical system, you are able to change boot order as needed. Just like you would in the real thing. You can choose what order to boot from. There is an option for dynamic memory, where a system can get the memory it needs or grow on demand as needed. Of course, you're going to need something like integration service already installed before you do this, because otherwise that'll go crazy. And you can choose what VM will get a higher priority if you have multiple VMs running at once. So in this case, we have a machine who has a gigabyte of RAM, but it can grow up to that amount just in case. Now, I don't remember off the top of my head if Hyper-V allows over-provisioning. I know VMware does. And if I had to take a guess, Hyper-V does too. Because we're talking about Windows, primarily as the operating system we're virtualizing, you want to give it 2 processors. If it's Linux, it could run with 1. The maximum 4 CPUs is the maximum physical that you have. So there's the option for that. Again, you can define the limits based on how much we're going to reserve, or the limit or relative weight by other systems that are running. There is a compatibility node in case you're moving this, or migrating should be the word, one VM to another, and the second machine has a different processor. Your hard disks, they are really just files. But just like on the physical systems, if you went with the generation 1, it can only hold up to 4. If it's generation 2, it'll be able to handle more at once. Because they're virtual disks, you can move disks around and not really have a problem other than, we don't have a boot partition, so it's not going to boot. Two big notes here. If you're going with a VHD file, it can only grow up to 2 terabytes, whereas VHDX is 64 terabytes. VHDX is the newer version of the virtual hard disk with some new features. There is also the VHD set, something that has existed in VMware for forever and a day, where you can take multiple files and turn into one disk. Because we're talking a virtual disk, we can make it grow automatically. As we need more space, it can dynamically expand. You can also set fixed disk size. A fixed disk size is good for things like databases. You can also have things like differencing disks. If you have multiple VMs that run the same OS, they could share the single parent. So basically, we're installing Windows once, and then 3 VMs could share that one base install and make their own from there. That would cut down on setup time. You can do some edits on a virtual hard disk. And these are pretty standard editing that you can do on a virtual hard disk. Networking can handle VLANs. So if we're setting up virtual machines and they're going to connect to the physical network and they have a specific VLANs, that they will be able to connect to those networks. And those do get passed through the software onto the NIC card, onto the wire. You can also do a number of things like DHCP guard, MAC spoofing, so on and so forth. Moving machines is generally easy. You can import and export. For the most part, that's the easiest way to get a VM off of one box and into another. Again, you can use, as Microsoft calls them, checkpoints. VMware calls them snapshots. So in case, let's say you have a test machine and you test a new piece of software, you want to do a snapshot before you begin, because in case things don't work out, you can just revert. Hyper-V does have a wizard that you can use to migrate your virtual machines out, and it'll copy all of these items together. The easiest way to make a copy is to export and then import somewhere else. It'll ask you for a unique ID. Make sure that it's different. It'll just save you the hassle. I mentioned all these things about checkpoints. Great for testing, great just in case things go bad, we can easily revert. It's one of the best features of a virtual machine. It'll have everything as that virtual machine was at that point. So if and when something goes bad, it is easy to revert back to that exact moment and resume as normal. If you have too many checkpoints, that can cause some issues, especially when restoring. You wanna manage your checkpoints. So here's an example of having our one machine, and then we have two snapshots. From this second snapshot, we made another one, and that's where we're at now. So just in case we need to go back to test case 1, we can do that, and that'll be another chain. And of course, we have some options to manage checkpoints. Any questions? Okay. I'll make a recording from that. And if there are no other questions, then I will end the stream.